sectored circle, right? The pie chart is a sectored circle. Now, no. Give me the. So the pie chart is a sectored circle, and that means so many things among others. It means so many things among others. What it means is that so especially those in social sciences and in arts, they use the pie chart better because they understand it better. Is it clear? Some people understand better with what? With pictures. Is it clear? So now let's go over to types of pie chart in the next paragraph. You may write. There are two categories. There are two categories of pie charts. There are two categories of pie charts. Huh? They are one, 2D pie chart or two-dimensional pie chart. And two, we have the three-dimensional what? Pie chart. Regardless of the category, one may have two types of pie chart. One may have two types of what? Pie chart. Namely, one. I'm going to explain. Namely, degree pie charts, and two, percentage pie charts. Percentage pie chart. Now, we are going to use the two of them quickly to address the problem we had. I think that was example 2, right? Was it example? The one we took, the first question we took on single bar chart, was it example 2 or 3? Example 2. That's the example I'm talking about. So we are going to use that data in example 2 to show how a degree pie chart and a percentage pie chart is used. Is it clear? So let's go over to a degree pie chart. In a degree pie chart, the angles of each sector, are proportional to the size of the commodity. The size of the commodity being represented. However, in a percentage pie chart, in a percentage pie chart, the percentages of each pie chart, or of each sector rather, of each sector are proportional to the size. Please, let's change this to sizes of the commodities. Let's make this plural. The commodities being represented. Okay? Full stop. We shall put up a degree and percentage pie charts for certain problems, as shown in example. What was our last example, please? What was our last example the day I left the class? Was it 4 or 5? 4. So this should be 5, right? As shown in example 5. Are we there? Now, so class, what am I saying? You may put your pens down if you have written up to that point. Please listen and listen good. So what I'm saying in essence is this. Story number 1 under pie chart. What is a pie chart? A pie chart is a pictorial representation of data. It's a pictorial way of organizing data, or a graphical way of organizing what? Data. Using a sectored circle. And by a sectored circle, it means that a circle is partitioned into different sectors whose angles or percentages are proportional to the sizes of the commodities we want to what? Represent. Is it clear, everybody? Now, if you go to your Microsoft Excel, or let's say any other statistical software that I know of, like Minitab and the likes, even SPSS, if you go to pie charts, you are likely to see two categories of pie charts. Pie charts could be 2D, 2-dimensional. Pie charts could be what? 3-dimensional. If you go to Excel at home, please, you will see some pie charts that are just like this. Where you see yellow, blue, those colors. Then you will see another one that looks like a coin. They'll put it like this. It will be solid. Then you will now be seeing the same partition is like this. This one is 3D. This one is what? 2D. Now, our focus is not on explaining this. The same principle applies to both of them, but our focus is on this one. Is it clear, everybody? Now, what I'm saying is that whether it is a 2D pie chart or a 3D pie chart, one thing remains certain. There are two types of what? Pie charts. It is either a pie chart, which may fall under 2D or 3D, is what? A degree pie chart. Or the same pie chart, if not a degree pie chart, is what? Is what? A percentage pie chart. Is it clear? So these are two types of pie charts falling under any of these two categories. I hope somebody understands what I'm saying. Now, what is a degree pie chart? In a degree pie chart, the angles of each sector, that is, a degree pie chart looks like something like this. It looks like this. So I could have here rice, and this angle, every sector has an angle. So rice, we may give 50 degrees. Okay? Then beans may be what? 160 degrees. We may call these beans. And so on. This is a degree pie chart. When you see this is a commodity like beans, represented by what? 160 degrees. This is a commodity like rice, represented by what? 50 degrees. How large the commodity is in size is as large as the what? The degree. Now, if you were using a percentage pie chart, this will not be what? Degrees. Do you understand me? This will be what? Percentage. This could be 70%. This could be what? let's say 150%. I'm just giving an example. Is it clear? So in a percentage pie chart, you'll be finding percentages. In a degree pie chart, you'll be finding what? Degrees. Is it clear, everybody? So that's what we are saying. Let us now look at example 4. In example 4, we are going to use the data of example 2. So can I wipe this off? Thank you. Did I say thank you to you all for joining, especially those who joined? Some of you went to World Champions League. Eh? And the fact that you guys were watching Champions League was even annoying me because as at that time, I was in the living room. The matches were playing and it was paining me. And my daughter was coming to knock on the studio room, asking me that I should change it to cartoon. I should change it to cartoon. I should come and change it to cartoon. So, surprise, surprise. I still watch the scores later on. Oh. That's how I got to know that what do you call them? Real Madrid. Real Madrid, I don't know what is wrong with Real Madrid. It's like some witches came at night to that stadium. Huh? Barcelona has come there to destroy them. And so also has AC Milan. How can AC Milan come to Real Madrid and give us, what do you call it? 3-1. Was it 3-1? 3-1. But you started with saying you didn't watch the match. It's live score. It's live score. So if it's live score, would you be watching live score for almost 90 minutes? Well, thank you so much for your support in recent days. I really appreciate it. I really, really appreciate it. I'm grateful. And so many of you who do not even join live, you actually go to make comments and all those things. Those things help. So I'm really, really grateful. From a sincere heart, thank you very much. So now let's take example 4. So example 4 says using, is it example 5? Okay, example 5. So using the data in example 2, plot or set up a degree pie chart. Set up a degree pie chart. B, a percentage pie chart. Are we there? So let's do the following. Now, please take notes. There are some of us who always want, the reason why we fail exams is not because we are not intelligent. The reason why we fail exam is because we want it to be very beautiful, what we write down. So we start putting lipstick, pancake, makeup. When you get into an exam hall, I don't know about you, but I'm just suggesting what I do. I'm always entering the exam hall very tense. And I have 2 targets. The first target is write to get 40. That is the 40 I'm talking about. It's not writing in the hall to get 40. That is write to get something that complements whatsoever you've gotten in assessment, you think you'll get in assessment, that will make a pass. Then you can now start writing for grade. So write to pass first, then write more for what? The grade you want. So when you know you've written convincingly to pass the course, you can now start choosing whether you want an A, you want a B, so you write more. Okay? Now, when a question on pie chart is given, the question is usually in an exam saying sketch. Sketch. The only problem with that sketch is that when we say sketch, some of you are so terrible. You do like this. Shade and same up with sketch. Knowing fully well that a pie chart should look like a circle. Some of us, because the question says sketch, they will do like this. This is now a circle. Sketch means draw what looks like a circle. Even though your hand is bent, just try to make it straight. Look at my own. Very nice. Very nice. So this is better than this. Don't say because it is scared. Some of you would even draw egg. Eh? So please, those who waste time in exam, don't start looking for a container that will draw a perfect circle. Don't start looking for is it compass or protractor? Which one do you call it? That you use compass, right? To draw a circle. No. The question says what? Sketch a degree or percentage what? Pie chart. If I were you, I would do this one. Don't do this. Don't do this. These are like you abusing the fact that we say sketch. Do something like this, not necessarily with a compass or any bottle cover. Am I understood? It saves you time. Now, that is the first level. When you now want to put the demarcations, nobody, including myself, will carry, what do you call it? Is it protractor now? The one you use to measure angles. Nobody will use a protractor and say, let's check whether the student actually measured 120 degrees. Nobody cares. Provided you can even do this. Let me shock you. You can even do this and call this one 120 degrees that looks small in your sketch. And this one you put what? 60 degrees. Provided that 60 degrees is what you got in your table and the 60 degrees is for rice and this is for beans. It is correct. Nobody is looking at this size. In geometry, we don't look at this. What we look at is what the size. That is, nobody look at the space. You look at what? The angle you have put. Is it clear? So don't start wasting your time to start doing measurements and all those things. Those things are not needed. The reason why we say what? Sketch. So let's exemplify what I've just said here. What was that data? Please, could you call that data again for me? The data was years and what? Years and what? Years, number of what? Cars, right? Number of cars, good. So for how many did we have? 210. To what? Good. This is another thing I want you to take note of. Please. See, this is 2010, right? 2011, 2012, 2013, 20 what? 14. Please do everything, all your calculations, do it in the table. Do all you want to do in what? The table. Let me show you how. So if they give me a problem on pie charts, what was this number? What was the number here? 5. The one here. 7. The one here. 9. The one here. Okay? 9. Okay, let's stop there for now. See what I'm going to do. We are going to continue the table above. Okay? So this is what I'm going to do. I'm going to create a space and call it degree. Because the pie chart required are 2, right? Degree and percentage. I'm going to call one space degree. Give enough space for it because you are going to do your calculation there. I'm going to call another space percentage. Now, this, if I had known, I wouldn't have drawn my space too small, but it's still good. I can squeeze it in. Now, let's continue the table here. We said it stopped at 2019. Is it not so? So this is 15, 16, 17, 18, and 19, right? Then I'm going to put a last colon for what? Total. I need the total. Come in if you are a student. It's coming. So this is what? Yes. Number of cars and what? Percentages. So see what you are going to do. Call the remaining years. Okay, the remaining years are 215, 216, 217, 218, 219. It's 219. Then what is this one? No. How many was this? 2, right? 1, 4, 3, 6. Now, when you add all these together, what would it give you? When you add, okay, this is 10. This is what? 15, 16. This is 26. Okay, this is 35. 25. This is 35, right? This is 44. This is 49. 49 plus this, that should be what? 56, right? Please add everything, confirm. That should be 56 if I'm correct. Is it 56? Okay. Now, if your total is 56, this is what you can do. You will now come, when you want to put your values in degrees, the first thing is compute the total. When you compute the total, come over to degrees and say for 5 cars, you will now have 5, the number of cars, all over what? Huh? All over 56 times 360 degrees. Whereas this one here that you are converting to percentages, you put the same 5 over 56 times 100. Is it clear? You come over to this one, this will be 7 over 56 times what? 360 degrees. This will be 9 over 56 times 360 degrees. This will be 10 over 56. That is each of them over the total times 360 will give you the corresponding angle. So this will be what? 9 over 56 times what? 360 degrees. Then come over here and put them in what? In percentages. This will be 7, right? Come, I hope you follow what I'm saying. So this will be 7 over 56 times what? 100. 9 over 56 times 100. 10 over 56 times 100. This is what? 9 over 56 times 100. This is what? 2 over 56 times 360. While this one is what? 2 over 56 times 100. This is 1 over 56 times what? 360. This is 1 over 56 times what? 100. 4 over 56 times 360 degrees. This is what? 4 over 56 times 100. This is 3 over 56, 6 over 56 times 360 degrees times 360 degrees. This is 3 over 56 times 100. 6 over 56 times what? 100. Now, when I prepare that, if I were to be you in the exam, everything will be in one table, making it neat. I don't do it outside my table. I will now come here, choose a decimal place to which you want to put your results. Let your results stay in the table. So I can take it to what? One decimal place or to the nearest whole number. You can give your result to the nearest whole number. So let's quickly bring out your phones and let's multiply, please. Give me, do it this way. 5 times 360 divided by 56. 32.1. So I need it to the nearest whole number. I'll just call it 32 degrees. And I put an approximate symbol there. Is it clear? The wave here shows that it's an approximated result. Hey, good morning. How far? I don't think I have any class after now. Now, do the next one. What of this one? How are you doing it? Have you done this one? 5 over 56. 5 times 100 divided by 56. That's 500 divided by 56. What will you get? I hope nobody's calculator is using fuel. 8.1. For this one, right? 8.9. That is approximately 9. So that's 9 what? Percent. Is it clear? Now, this is what? Approximately. Okay, so approximately 45 degrees. You have a right to say he's lying, you know. You can compute your own. So, what about this one? 700 divided by 56. Approximately, what would it give you? So the nearest whole number. 13. Approximately 13%. You see it. Do the next one. 9 times 360 divided by 56. 57.8. That's 58, approximately, to the nearest degree. Then 9 times 100, that's 900 divided by 56. 16. So 16. That's is it an approximate value? Okay. 16. So 16%. Now, 10 times, that is 3,600 divided by 56. What would it give you? I need the answers from anybody. The fastest finger. This one. 64.2, that's 64 approximately degrees. Then this one, 1000 divided by 56. 17.85, that is 18%. Then 9 times 360 divided by 56. What is it? 57.85, that's 58 degrees approximately. Then 900 divided by 56. You know why I'm rushing this class? 9 times 100. What is it? I had a female voice. 16. Okay. It's like in this class, women don't talk. Eh? 2 times 360, that's 720 divided by 56. What will it give you? Eh? 13 degrees. 13 degrees, correct now? 13, approximately 13 degrees. Then this one, 200 divided by 56. What would you get? What would you get? 3.9, that's approximately 4%. Good. This one, 6.42, that is approximately 4 degrees. 4 degrees, right? Hey, 6.42, 6 degrees, 6 degrees. Then this one, 1.7, that approximately 2%. Then this one, 26. 26, is it approximately? Yeah, 26 degrees. Then this one, 400 divided by 56. 7.1, approximately 7%. This one, 19 degrees, approximately, right? No, just, so, do you see it? I'm not going to put that way because it's not an approximate answer. I leave it that way. Then this one, 3 times 100 divided by what? 5.3. So this is approximately 5%. Then 6 times 360 divided by 56. 30, is it 38 point what? 38.5, that's 39. Go 39. So 39 degrees, then 600 divided by 56. 11%. Good. Thank you very much. Now, usually, if one is marking, they would add all these values to see that it gives you 360. And they will add all these values to see that it gives you 100. But if they add it, and it is really within the range of 99 and 100, 101, it's correct because they know that you approximated. That's why you have to put this approximation. Is it clear? Because the approximation may make your value above 100, above 60, or below it. So it is understood. Now, once you prepare this table, you have finished solving the question, you will now come over. This is where you now do the sketch. I will now call here, I will say question A, solution, and question B, solution. I will now do this to draw a fine circle that women draw. You can tell a girl at that point in time, please, can you help me draw? Anything you see, take it to. Hey. Okay, so I will locate my middle for both of them. I will now move over, come over to degree. Let's start with the degree pie chart. Is somebody looking at the board? Let's start with the degree pie chart. Which one is the greatest? How many do you need? 1, 2, 3, 64, right? So I will just call, I will partition them. 64 is the greatest, right? I can just start from here and take this one to be what? I'll put here an angle and put here 64 degrees. What would you call 64 degrees? You will call it what? You will call it 10. You will call it 10. 10 cars. Then what do you call it? The next one is which one? The next one is some people, you can even put here 10 cars and you put here 213. You can even use either of them. You can just put there 213. Is it clear? Whichever one you use, you are correct. Now, the next one is which one? The next greater one is 58. So I will take 258. I can take these ones and call them 58, 58. 58 degrees, I'll put here 212. 58 degrees, I'll put which other one? 214, right? Or 9. You are correct. So, the next one is what? 45. I can just take one now and call it 45. I've told you nobody's measuring your angle. 45. 45 is which one? 2011. Good. Then the next one is what do you call it? 39. 39 is 219. I can just take 39 degrees 219. Then the next one is which one? 32. 32, I can just take this and call this 32 degrees 2010. Right? The next one is 26. I can just take here, and 26 degrees is 217. Do you see it? I'll now be left with how many? 3, right? 19 degrees is what? Is 2018. Eh? Then the remaining ones are what? 13 degrees, I'll put here 215, and 6 degrees, I'll put here what? 216. Do you see it? I am not measuring anything. Now, it can happen that 64 is smaller than 58. Nobody cares. You understand me? Provided you put the information, this is what we really want to see. This one is a sketch. Now, if you do the degree pie chart, it makes it very easy. If I were you, what I would do, I would do the degree pie chart first and copy what I have done exactly and make it look like what? Percentages. So I will do this. This is how I started, right? I'll do this. I'll do this. This. You see it? Then I will now put, don't put this again because you're not dealing with angles. Is it clear? Instead of 64, what will you put? What's the angle, the percentage? 18%. And I'll put there 213. 58, the 258, we are 16%, 16%. I'll put here 16%, 16%, and I'll call them what? 212 and 214. Do you see it? I hope you understand what I'm saying. Then I will come over here and put 45 degrees was how many percent? 13%. I will just put here 13%. What is the difference? Take note, I'm not putting any angle here. What is 13% now? 13% should be for which one? 211. Then this one that was 39 degrees. 39 degrees was this one. What was the percentage? 11%. I will just put here 11% and put there 211. 219. Then 210, 32 degrees. 9%. So I will just put here 9% and I'll put there what? 210. Then 217, 7%. So 7% and I'll put what? 217, right? 217. Then the next one, 218. 5%. Then the last one is what? 215, 216. 215 will be what? 4%. You see it? And 216 is what? 2%. And that's all. Which one? Where is it? 216. This one?
Yeah, here.
Oh, thank you very much. Thank you. Okay, so please, what we have just done is to produce the degree pie chart and what the corresponding percentage pie chart. Is it difficult? Let's move over to the next chart. So the next one we had to go to was which one? After the pie chart, we had to go to which one? Was it the box plot? Was it the box plot? Box plot. So please, may I wipe this one off? That's the question. Okay, please. I'm giving you a minute. Do that quickly. Let's move over to the box plot. Let's move over to the box plot. If you are snapping, I should be able to wipe it. Is it not so? So. Hope I'm not in the picture. If I'm in the picture, let me smile. Everyone like. The total for which one? No, you don't need to. You don't need to know. Thank you. Now, please write the box plot. Box plot. Box plot. Box plot. A box plot is a graphical representation of what is called the five number, not five numbers, so five number summary. That's why I'm putting hyphen in between. The five number summary. So there's nothing like a 5-day summit. It is a 5-day summit. The 5 number summit. Full stop. So the first paragraph answers the question, class, what is a box plot? The box plot is a graphical representation of what? The 5 number summary. Is it clear? Now the question is, if I were to be on that side, that is listening to you, the next question I will ask you is, sir, please, what is the 5 number summary? Is it clear? So in statistics, paragraph, second paragraph, the 5 number for any data set comprises the smallest value in the data set known as the minimum, comma, the first quartile, what we call the first quartile. When we get into what you call the measures of central tendency, all these things you understand them. You understand me? But for now, the kind of question I'm going to give will require so many things. I just want to show you how to plot what? The box plot. Is it clear? But when we get into measures of central tendency, I'm going to show you how to calculate them. So this is what I'm going to do. So the first quartile, that is called Q1. The median or second quartile. The median or second quartile called Q2, and okay, the third or upper quartile, called Q3, and the largest value in the data set called what do you call it? Q, not Q, just called maximum. Full stop. Okay. Now I'm going to repeat my statements there. Everybody should know how to plot the box plot. Do you know where the idea of a box plot came from? The idea of a box plot can be compared to the mouth of a dog. The mouth of a dog, or the mouth of a cat, or the mouth of a lion, for one reason. I remember in primary school, there's one song we used to sing there when we played. 1,6. We'll be using that song to draw one cat. I don't know if you did that, something like that. I heard that game because I never knew what they were saying. Now, if you say draw a cat now, somebody like that will put here. Then the eye, the nose, and he puts this. What do you call this stuff? What's the name of this stuff? What? Whiskers. Good. Another name for a box plot is the box and whisker plot. Eh? So this is how a box plot looks like. A box plot looks like this. You can plot it horizontally. Please look up, everybody. Look up, look up. A box plot can be plotted horizontally or can be plotted what? Vertically. So there is a box, and at the end of this box, you have this same thing that comes out from the mouth of a cat with two lines. These two lines are called whiskers. You understand me? They're called what? Whiskers. So you can have a box plot in this manner. You can have it vertically, you can have it what? Horizontally. Is it clear? Now, when you plot a box plot, please listen. The box does three things and the whiskers do two things. So if you plot a box plot like this, put a graph sheet here, see how it will look like. So you can put a graph sheet around it. Now, this whisker here leads to the maximum point. If you drag this maximum point here, this is called the maximum value. This one here will correspond to what? The minimum value. Eh? The middle of this plot what is called the median. This point here will correspond to what is called Q1. And this point here will correspond to what is called Q3. How many numbers do you have there? 1, 2, 3, 4, 5. So when a statistician tells you, give me the 5-number summary for a data, he wants you to extract from that data the smallest value, the maximum value, the median, the first quartile, and the what? The third quartile. Is it clear? That is what we refer to in statistics as what? The 5-number summary. Now, the only graphical technique that displays basically the 5-number summary is what we call the box plot, also known as the box and whisker plot. Am I understood? So what we are going to do now, I'm going to just give you a simple question as example what? Let's take example what? 6. So example 6 says, example 6, using the information below, sketch a box and whisker plot. Sketch a box and whisker plot. A is for me, B is for you. Are you hearing me? That's where our class will end for today. But A, I will do it. B, you will do it, and I will go around, starting from here to the boys' quarter. I want to see what you guys are doing. Because God will not allow it that my own students will do what was done on social media. What do you call that stuff? This question for those at the back. For those at the back. What did that say? It now said, does the pressure increase or decrease? And those bad boys at the boys' quarter, they say, because they were not paying attention, raise. Crease. Then the last one is what? Creases. I'm going to go round. B is your own. Let me see how you do that nonsense. So A is for me. I'm going to give you minimum. Minimum is 15. Q1 is 10. Q1 cannot be 10. Q1 is 19. Q2 is 25. Q3 is 29. And maximum is 40. So next one, minimum is 6. Q1 is 9. Q2 is 13. Q3 is 17. And maximum is 23. Now, hello. I don't like my class being noisy. This is my last example in this class. So, question says, sketch the what? The box plot. Please, this kind of question cannot be given to you in the exam. In the exam, they would actually give you data. and you will be the one to compute. The only thing you will not compute is just to get the minimum. The minimum is the smallest value in the data set. The maximum is the largest value in the data set. But this one, and this one, Q1, the lower quartile or first quartile, Q3, the upper quartile or third quartile, and Q2, the median, you have to compute them. By that time, you would have known because I would have shown you. Is it clear? But for now, because we are focusing on how to plot or sketch the box plot, we are just going to give a summary information, then use it. Am I understood? So let's do it here. Can I have this off? Endurance, how are you? So let's sketch. So, solution. I'm using a vertical representation, so I'm going to use this. Please look up everybody. If you have your graph sheet, you can just choose any scale of your choice. See what I'm going to do. Let's assume that you have a graph sheet. This is the box plot. Look at my information. They are in 10. Is it not so? So the largest is what? 40. I can use 5, 10, 15, 20, 5, 10, 15, 20, 25, 30, 35, 40. So it should be enough. You see, use 5, 15, 20, 25, 30, 35, 40, 45. You see it. Then horizontally, I don't need any scale here, so I can just let it be like this. But I'm going to show you what to do there. Now, if I want to plot or sketch that box plot, I will now come over. Look at the information they gave me. They told me that my minimum is what? 15. So I can decide to leave 2 spaces, use it, and come over to 15 and concentrate on the next 2 spaces. So I'm going to take from here to trace my box plot. I'm going to draw my line here up to 2. You see the size. So I'll clean this off. Then that is 15. Then what is your Q1? Your Q1 is what? 19. If this is 20, 19 should be somewhere here, right? I can just trace it down to 19, starting from here again, 2. Then in the middle of this and this, I will drag this up. Do you understand me? This is my first whisker. Then, what is Q29? I will drag this up to 29. This is where 29 should be, right? I will drag this up to 29. Put it down. Where is my 25? I will put my. You see. Then, where is my maximum? 40. This is 40. I will drag my whisker to 40 and put this. You see what I've done? So, this is a 5-number summary using the box plot. What have I done? This, if I now look at, if somebody gives you the box plot now and say, extract the 5-number summary from the box plot, that is, they just gave you a graph like this. They didn't give you this information. You just know that the box plot is a graphical representation of a 5-number summary. The lowest should be the minimum. And if you trace it down, you just know that the minimum was 15. The Q1 should be what? 20. The minimum is 25. The maximum is 30. And the Q3 is 30. And the maximum is what? 40. Please get this second one done now. I'm giving you 5 minutes. Okay. Let me move around to say. No, don't engage. So, is it time to see nonsense or see sense? Which one are you going to see? All of the above. Okay. But provided I see nothing like creases. Creases is the one I don't want to see. The guys at the boys' quarters. And now you won't ask for a ruler. Can attempt, get something done, do something. You understand me? Do something. Some of you will start pretending. Now, when I come close, that's when you now want to keep serious face and start pretending as if you are doing something. I will know. box plot. Which one is our next graph? Eh? I'm talking to people, not myself. Bro. What's the next graph after the box plot? Eh? Histogram. So please get that done. I will see it in my next class. Thank you very much. Who said thank